In this video, we ask the simple question, do you gain or lose from riding the yield curve? First of all, let us remind ourselves about what the yield curve is and bond valuation. In valuing future cash flows, the market uses different rates depending on how far in the future those cash flows are going to be received or paid. And this creates a certain shape that is normally thought to be upward sloping. Normally it's upward sloping. So if you have a cash flow of that is, say, 5 years in the future, you're going to discount it at this discount rate. If it's only 2 years, then you're going to discount it at this discount rate. So cash flows at different times will get discounted by different rates, and that is called the yield curve. When we look at a bond, we have our relatively familiar cash flows of the coupon payments and then the final payment of £100. So in this example, it is a 5-year 5% bond. We get £5 in the first year, £5 in the second year, and so on. The market treats these as cash flows in the future and applies different discount rates. In this case, we take a discount rate as an example of 1% in the first year, 1.5% for 2 years for the second year payment, and for the payment in the third year, we discount that at a rate of 2% a year, and for the fourth year payment, 2.25% a year, and 2.5% for 5 years. So we apply these different discount rates, and note that these are per year discount rates. So the third year cash flow is going to be discounted at 2% a year, right? So 2% in the first year, 2% squared in the second year, and divided by 1.02 to the power 3 for the third year. So I take it that you're reasonably familiar with that calculation of present value. But it is not discounted by 2% in the third year, 1.5% in the second year, and 1% in the first year. It's not discounted like that. These are constant per year rates, in this case over 3 years, this case over 2 years, and so on. Right, so that's our basic valuation. Here are the present values of these cash flows, and this is the current value. So the question that arises is what happens if we hold the bond for 1 year? What happens to its value? Does it go up or does it go down? And this holding for 1 year is what we are referring to when we talk about riding the yield curve, because it's as if we start out at 5 years and then we hold it for 1 year, and therefore it's gone down to 4 years. And a preliminary view of this problem is that if it goes down to 4 years, then our discount rates for what was a 3 year is now a 2 year. What was a 2 year is now a 1 year. And those rates are going to be lower, and therefore the value, the present value, is going to be higher. So we're going to make a return. And that is more or less the story that we see here. So if we look at it in detail, we see that there's, for the first year coupon payment, that is paid at the end of year 1, and that is the beginning of year 2. So here, this is, in fact, the valuation here is at the end of our original year 1. And that is going to be £5. So we gain the £5 and lose the present value of that £5, which is the £4.95. So I've put green for gain and red for loss. What is going to be happening here is what I was saying earlier about the discount rates. This discount rate was 1.5, and this coupon payment is now going to be discounted by 1%. So it's going to be discounted at a lower rate, and that's going to have a positive effect on the value of the bond. Then another positive effect is going to be the fact that this coupon payment was originally discounted by 2 years, and now it's only going to be discounted by 1 year. So it's going to be discounted by fewer years at a lower rate. Both those effects have positive value on the bond. So we shouldn't be too surprised that the value of the bond goes up and the return is positive. Whether it is better or not compared to holding the bond to maturity, well, that has the grand assumption that the yield curve remains constant, which over 5 years, which is not going to happen. So there's little point in making an unrealistic assumption. Suffice to say that one would have to use a spreadsheet and try out various scenarios. Now let us have a look at the position of a downward sloping yield curve, and for that we have a yield curve discount rate, as you can see there, going from 3.3 down to 1.5. So here we have this situation where the discount rate is higher than the original 1.5. What we have is quite a dramatic change in our discount rate. So this is clearly a higher rate. So our second year coupon payment is going to be discounted by more than the 1.5, so that's negative. And this 2.9 is higher than the 2 up here, so that again is a negative effect. However, the number of years is going to decrease, and that is going to have a positive effect on our valuations. Looking also at the third and fourth years, it would be reasonable to assume that these are probably going to be lower than these because it's downward sloping and not upward sloping. So here it's 2.1 instead of 2.25 and 1.5 instead of 2.5. So these are beneficial effects. So although it's downward sloping, we can still see that there is a return. And in fact, in this particular example, the return is higher than a constant yield curve. So you can see that it becomes really quite a complicated calculation. And if we are to work out a downward sloping yield curve with loss, well, it's rather difficult in this example because it's quite a short-term bond. With a longer-term bond, as I'll show in a minute, it will possibly have a greater effect. But we can see that the negatives are now across the board on these discount rates. So it's 7654, and all of them are higher than this. And that has a negative effect. So there are two effects going on, one that it is higher and the other that it is negative. So on that basis, that is negative, but this remains positive. So we'll have that in green and bold. So that effect remains positive. We're discounting by less. However, the higher discount rates and the fact that it is downward sloping and higher means that the return is now negative. So all this shows is really that a negative return is possible. Now, if the bond, if we look rather at the individual differences, you can see here that well, with this downward sloping demand curve here, you can see that there's no difference. In other words, the higher interest rate from 1.5% to 3% has been totally offset by the fact that you're discounting by 1 year instead of 2 years. And for this cash flow, you can see that this is again, well, it's not again, this is slightly better, in fact. Although it's 2.9%, the fact that it is now 2 years discounting instead of 3 years has had a net positive effect. and a positive effect here, as you would expect, because both are positive, and a positive effect here. And the other thing to note is that the positive effect here is absolutely bigger than all of these coupon payments. And it's the same story here, only here it's a negative effect. And you can see that this difference, this fall in value, is very much greater than any differences in value of these amounts. So the downward sloping demand curve would have a bigger effect the further away or the longer the term of the bond. But we haven't illustrated that there here, so you just have to take that as an extension of our observation that the biggest effect is this one here, and also that the greater effect here is in fact the higher interest rates rather than the fact that it's downward sloping. But the downward sloping does have an effect on the discount rate. And by pushing up the shorter term rates in particular, but as you can see, it does depend on the longer term being discounted by a lower rate. See what effect that is. So there are pluses and there are minuses. Whether they balance out to a positive return or a negative return is a matter of simulation in practice, and there is no simple formula for its effect because there is no formula that guides the yield curve. It is determined by market trading, and we can't easily put its shape, which is often a rather difficult one. We can't easily put that in the form of an equation, and therefore we can't make generalizations about the effect of a change in the shape. Okay, so that concludes our look at riding the yield curve.